Bugs in Code. The problem that I'm going to explain today is max min height. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe my channel so that you never miss out an update. So let's get started. Here's the problem statement, and it says that uh, you have a garden with n flowers. But before that, I want you guys to know one thing, that this problem is something which is really very tricky, and I don't recommend you to skip this part, because here I'm going to give you the clean explanation about this problem statement, what the problem is exactly saying. So the problem says that you have a garden with n flowers lined up in a row. The height of ith flower is the height of ith flower is ai unit, and you will water them for k days. Okay, so basically we have some flowers with the given height and we are going to water them for k days. In one day you can water w continuous flowers. Whenever you water a flower, its height increases by 1. Okay, so when I water any flower for the first day, its height increases by 1. You need to maximize the height of the smallest flower of all the time. Okay, one example is also given here. Let me explain the example. This example is going to give you like the clean explanation about the problem, how it is going to be solved, and what the problem is actually saying. This is something which is important. Okay, so we have n equals to 6, k equals to 2, w equals to 3, and height is something which is given here, and it is 2 2 2 2 1 1. So we have 6 flowers with given height. Okay, so like I have flowers like these are the flowers, and two small flowers. Isn't it like 2 2 2 2 and 1 1? After that, when I water any flower, so it is going to increase its height by 1. So this is going to be 3. Now for the first day, for day 1, like day equals to 1, I can water either these 3 flowers, because I can like water 3 like w continuous flower in a day. So I can either water these 3 flowers, I can either water these 3 flowers, I can either water these 3 flowers, and I can either water these 3 flowers, isn't it? Let me write all the possibilities that I have. The possibilities that I have is, what happens when I water these first 3 flowers, then the height of these becomes 3 3 3, and the rest height remains same, like 2 1. What happens when I water these 3 flowers, then my height will become 2 3 3 3 for these, and 1 1. When I water these 3 flowers, then the height is something which becomes like 2 2 3 3 2 1. And at last, when I water these 3 flowers, so the height becomes 2 2 2 and 3 2 2. Is there any other possibility? No. Out of this possibility, let's assume that we have only one day instead of this 2 days. So for the one day, I'm going to find the minimum here. The smallest flower is 1, having height 1. The smallest flower is having height 1. The smallest flower is having height 1. And the smallest flower is having height 2. Now, this is what the problem says. Out of all the small height of smallest flower, I have to return the maximum height, isn't it? So if the day would have been 1, then I will be returning 2. But since the day is not 1, so let's move further. Let's move further. For the day 2, again I have possibilities. So I will have some possibilities. Whatever I have doesn't matter. I will have again 4 possibilities and 4 possibilities here. Out of all these, whatever my final answer comes, like these, I'm going to have some final answer, and I have to return the maximum height of the smallest flower out of all these possibilities. So this is what the problem says. I hope you guys got the clear understanding of the problem, and out of those possibilities, the minimum height is going, like maximum height of the minimum uh, flower is going to be 2. So this is what the problem says. Now let's move to the solution. Let's move to the solution. So I'm going to write solution here. If you see the structure that I have drawn here, so what this structure says? This structure says that, hey, the problem to this, like the solution to this problem depends on the problem solution to this subproblem. So this is something which is following optimal substructure, isn't it? So from here you can see that this problem can be solved with recursion. There is no doubt because each time I'm going to calculate the value for all the windows, like window of size W, and then I'm just going to return the maximum of those. Like for day equals to 1, the maximum it is going to return 1, it is going to return 1, it is going to return 1, and it is going to return 2. And out of all these, the maximum is 2. So for day 1, 2 is going to be my answer. No doubt. Again, I have these possibilities. So I want to write some of them, few of them. Like for this, if I like perform operation for this one, then the height finally I'm going to have like for this one remains same, for this one remains same, for this one, and for the last one it becomes 3 3 3 3 2 2, isn't it? For this one, this particular case. Okay, again I'm not going to write for all these like 1 2 3 4, so don't have this 1 2 3 4. I'm going to write for this. For this, if I include the first test case, so it is going to give me output like height of these is going to be increased. So 3 3 3 3 and 2 2. Now you can see that this is the same subproblem which is present here. So we are solving same problem subproblems again and again in a different tree. But why to do this? Why to do this? This is going to increase the complexity. So I can see that I have overlapping subproblems. There's no doubt. So from these two components, we can see that the requirement for dynamic programming problem is being like accomplished or being completed, being fulfilled. So this is where we can say that dynamic programming is something which can be used to solve this problem. Dynamic programming. Now, why I have told you this? This is something which is the brute force, and this is going to give me time limit exit. But I told you this because no one is talking about this. Like in the topic text, if you see the topic text of this problem, so topic text contains dynamic programming. So this is how dynamic programming can be applied. I have just told you how dynamic programming is used to solve this problem. But the approach, so I hope you guys got the idea about how it can be solved with dynamic programming. So you can write the code. If you don't like, if you're not able to write the code, then you can ask from me. I will do it for you. And now the approach that I'm really interested to explain you is something which is binary search. This is also something which is given in the topic text. So we got an idea that okay, this problem is going to be solved with dynamic like binary search, but how? This is the question. I'm going to write the same example again. Let me make it thinner. So I'm going to write the same example again. N equals to 6, W equals to 3, K equals to 2, and I have 2 2 2 2 and 1 1 as my heights. Now here, what is the minimum height that I can have? So okay, if I talk about the problem like constant of this problem, so constant are something which is k value lies from 1 to 10 raised to the power 5, and the value of ai, which is the height of a particular flower, it can be at max 10 raised to the power 9, and the minimum height can be 1. Now you can see that the minimum height can be 1. So if I have 1 as my height, and if I don't like water this flower for any day, so I'm going to have minimum possible value is 1. There is no doubt. After that, the maximum possible value that I can have, the maximum possible value that I can have is like the height is 10 raised to the power 9, and if I water it for k days, so k have maximum value as 10 raised to the power 5. So my max is something which is going to be 10 raised to the power 9 plus 10 raised to the power 5, because the height will be increased by this much time. So I'm not going to calculate this. Instead, I'm going to write this is something which is surely going to be smaller than 10 raised to the power 10, isn't it? There's no doubt that this is something going to be smaller than 10 raised to the power 10. So I can have the maximum height as, remove this, I can have the maximum height as 10 raised to the power 10. So not equal to, but it is the maximum possibility that I can have. Now what I can do is I can run a loop from I equals to 1, like for I equals to min I is smaller than equal to max. In this loop, I'm going to check if possible. What possible? Possible what? If it is possible to have current I as my minimum height in the array after performing the operation for k days. This is something that I'm going to check here. Like I'm going to check for this possible. Let me write let me even write this. So whether it possible, whether it is possible to have min height, min height as I after uh, performing the operation. So this is what this function is going to return. So if it is true, like if possible returns true, so it says that yes, I can have the minimum height as I after performing the operation. So I'm going to store I in my answer, and after that I'm just going to increase. I is obviously increasing itself, it's a for loop, so I is going to increase, and it is going to give me the maximum value, isn't it? So because I'm not breaking here, so it is going to run, and the last value for this condition was true is going to be the max value. So at last I'm going to return max. uh, this time I don't want you guys to focus on this particular function. You can suppose that this is an abstract function which just returns the like the solution for us. We are not interested in the implementation for now. I will obviously tell you the implementation later. So for now, I'm not interested in the implementation. Now we are done with the linear search. But can we apply the binary search here? Can we apply the binary search? Let's check. We have the value from min to max. So these values something which is which are like in the sorted order. How? 1, 2, 3, 4, 5, 6. This is how I'm running my loop, linear loop. So these are the like sorted order values. So what I'm going to do is I'm going to take any value in the middle as x. So for this x, if possible, like possible for x. Now again, possible is my same function that I have explained you here. So just don't worry about the possible. So if possible, then what happens? Possible means that hey, it is possible to have like min height as this value. So can we have some greater answer? Of course, x can be my answer. So I'm going to store answer equals to x. Why? Because answer x is now became a candidate for being an answer. But is there any greater value? Because if I found any greater value, then I'm going to make that answer. So I'm going to move my minimum, which was here, minimum from this point to this point directly. So my minimum will become x plus 1. Now you can see that okay, not x, actually this is the value and index is mid, so mid plus 1 is going to be mid. Now I'm eliminating all these values. If you notice here, isn't it, I have eliminated all these values. But if it is not possible, what is going to be the case then? If it is not possible, then if it's not possible for x, it is not going to be possible for any value greater than x. Do you understand this? Okay, if you don't understand this, I'm going to explain you. If I have height as 1 and I have to increase this height to 20, but I have only 5 days. So is it possible to increase 1 to 20 in just 5 days? In each day, I can increase my height by just 1. So of course, it is not possible because at most my height can be 6. I can't increase my height from 6 to like 20. So it is not possible. If it is not possible for 20, then I'm sure that it is not going to be possible for 21, 22, 23, or any value greater than 23. That's what I'm saying here. So if it is not possible for x, then I'm going to eliminate all the values greater than x, and I'm going to move to these values which are smaller than x. So my high, which was at here, like max, which was at here, it is going to be at this point. So now max is going to be here, and this is something which become my search space. So my max will become, in the else case, my max will become mid minus 1, no doubt. After that, if you see there, what is the value till when we are going to run this loop? While my minimum is smaller than equal to maximum. This is something which is working as a pseudocode for this problem. Now guys are going to ask me, hey, can you please tell me how this possible function work? So now I'm going to explain you what exactly is the possible function and how it is going to work. So now start with the possible function. So possible function says that whether possible function. This function says that whether it is possible to have minimum height as mid. Okay, I'm writing mid here because mid is something which is highlighting that we are having the min index in the mid in the binary search. So that's why I'm writing mid. So is it possible to have mid as minimum height after performing the operation? Operation is nothing but watering the flowers. So don't get confused what is the operation here. Operation is something watering. If I am giving water to a flower, then I am performing the operation. Okay, now I was given the array as 2, 2, 2, 2, 1, 1. These are the heights of flowers, each flower. Now, if I check for like m equals to 3, okay, mid equals to 3, I'm going to write all the other values as well. Like, what was the number of days allowed to us? 2. What, how many flowers I can water continuously? 3. And what are the number of flowers? 6. It is not required because 6 is something which is the array of size as well. So now I'm going to check whether 3 can be my minimum or not. So how to check it? Simply, if I want 3 as my minimum, so I'm going to like increase all the value which are less than 3 because I want 3 as my minimum. So any which is less than 3, I don't want that. I'm going to increase that value up to 3. Why not greater than 3? Because greater than 3 which is like non-relevant because I want to minimize my operation. So I want to minimize the days in order to like minimize in order to have the optimal answer. So now if I check for this particular condition, then 3 is my minimum height and 2 is the height here. So 2 is smaller than 3. So I'm going to make this 2 as 3. What is the difference? 1 is the difference. So I need to increase this 2 by 1. How many days are required to increase the height of any flower by 1? Days equal to 1. So I'm also going to keep track of like days that I have used. So I'm going to write day equal to 1. Day is 1. I have used 1 day and I have made this flower as 3. Now I'm going to check for this as well. This is also smaller than 3 and I'm going to increase the height of this as well. But the question is how to increase the height of this. I mean, why to increase the height of this? If I increase the height of this, then I have an advantage that I can increase the height of k flowers like w flowers in the front as well. So just do it now because this is something which is going to optimize my solution and I don't have to like I will not need to do this for this now. So in order to have the optimal solution, what I'm going to do is like I am going to increase the height of this one, and this one, like K W flowers. So do it. This will become 3, this will become 3, and this will become 3. After that, I'm not going to check this because it is already 3, it is already 3, and let's come to this. This is something which is again smaller than 3. So I'm going to make it 3. Again, the difference is 1. So increase the height by 1 and increase the day by simply day now we will become 2. Now I have spent 2 and I have made the height of okay. Now let me write the heights again because this is something which is messed up now and I'm going to write the new heights here. New heights are 3 3 3 3 and these are also going to increase this because this is the size of window that I have like W. So this is going to be 3 2 2 1 2 3 4. Okay, now this is the height, these are the heights that I have. Now I'm at this particular index because I'm done with this. I'm at this. This height is also smaller than 3 unfortunately, so I'm going to increase this height as well. Again the difference is 1, so it is going to be 3. Now my days are 3 and I'm going to make it as 3 and I'm going to make it this as well 3. Now all these are 3 3 3 3 3 3 3 and the minimum height is again going to be 3. Now I am done. I have performed the operation and I have made my minimum height as 3. So is it possible? Let's check if it's possible or not. So days I have spent is 3 and days allowed to me were only 2. So this is where I am facing the problem, and what I'm going to do now is I am going to simply return days smaller than equal to k or not, because days smaller than equal to k I have utilized just less than k days. So yes, it is possible, and if I have utilized more than k days, so it is. Now I'm going to write the pseudocode for this. Just focus here. I'm going to run loop for I equals to 0. If you guys have noted that thing, then it's good, and I'm going to write again here because it's important to understand. I'm checking for each value. So for I equals to 0, I smaller than n and I plus plus. Okay, simple. Check if current height, like a of I, is smaller than like if it is smaller than my mid, like the minimum height that I want, if it is smaller than that. So now I have to do something, because when 2 was smaller than 3, then I was increasing the height of 2. Increase by how much time? So I'm going to have a variable which is different, and which is going to be like mid minus ai. This is the difference by which I have to increase the height. So if I increase the height by this difference, so my days are going to increase. So days plus equal to difference. My days are going to be increased by this factor. After that, am I done? No, I'm not done yet. I have to do one more thing. I have to make all these W values increased by 1. I mean increased by difference. So for that, I'm going to run a loop again, one more loop. J equals to I, and j is smaller than I plus W and j plus plus. Make this height as like array of I plus equals to difference. Isn't it? Quite simple, no? The problem is solved now. And if you see here, the complexity is something which is going to be of n cross W. This is something which is really very bad complexity, and I want to optimize this thing. You can see that I'm running this loop and this loop here, but the question is, what is the component which is increasing complexity of this statement with W, like this code with W? Isn't it this component? This is something which is causing the problem. How to optimize this, and what exactly this is? This particular component is nothing. It's saying that simply that how to find, like, okay, find uh, some, like, okay, not find, actually I have to write increase the value from L to R by K in an array. This component is something which is causing problem. We are doing this option O of n cross W, but I'm going to do this operation in just O of n. How I'm going to do this? Focus here, because if you understand this component, then this problem is easy for you, and this is very simple part. Let me tell you how simple it is. Okay, now this is something that I have to explain you. So I want you to assume an array. Assume an array which is 1 2 3 4 5 6 7 and 8. Okay, take a simple example which is an array which is 0 0 0 0 0 0 0 0. I have to increase the value from this L to this R by 1. How I can do it? How I can do it? Tell me. I can do it simply by adding 1 here and calculating the prefix sum, isn't it? Like if I add 1 here, so this will become 0 0. Like array of low becomes 1, or k if I want to increase by k. Array of low becomes k. Quite simple. I will make it k, and after that I will calculate the prefix. Okay, so this is 0 0 k 0 0 0 0 0. This is now something my array. I'm going to find the prefix sum of this array. Prefix sum is going to be calculated as 0 0 k k k k k k. Is this what we want? We want our sum k from L to R. After that, I don't want this. So this is something which is like mm, not needed here. But how to like do something which is going to neutralize the effect of this plus k after at this point and after this point? Simply minus operation. Like if I want to make 4 0, then how I can make this 4 0? By doing minus 4. Simple. So in order to neutralize the effect of this k, simply I'm going to add minus k. So k minus k will become 0. And what I'm saying, I'm going to tell you here. If I make like I have made already array of low as equal to k. After that, I'm going to make array of like right plus 1 equal to minus k. What it is going to do for me? Let's do this operation, then you will going to understand. If I have 0 0 0 and I have written like k here 0 0, and after that I'm going to write minus k here and 0 0 0. Now what I have done here, now at this point after I calculate the fixed sum of this array, then it is going to be 0 0 k, then k, then k, then k minus k 0, and then 0 0 0. So I'm done with my approach. At this point you can see that I have achieved something very interesting. I have added the value from L to R as K, and I'm not doing any of like n cross W operation. So doesn't matter how many value I have, how many queries I have. If I'm going to perform like from in this range I have to add k, and in this range I have to add L, and in this range I have to add like Z. So I'm going to write this formula, and at last I'm going to calculate the prefix sum, and this is going to work for me. Let's see one more example. It's quite time consuming, but I want you to make a clear understanding of this, because this concept is something which is used in various problems, and even I have solved two problems based on this concept. So if like I have 0 0 0 0 0 0 0, and I have to add 2 here, and I have to add like 4 here. So how we are going to do it? We are simply going to put 2 at this point and minus 2 at this point. So 0 2, and after that I'm going to add 4 at this point, so it will become 4, and after 0 here I will have minus 2, and here I will have 0, and here I will have minus 4. Now calculate the prefix sum of this array. Prefix sum of this array is something which is 0 2 6 6, and 6 minus 2 is 4, and then I have 4, and then I have 0. Is it something that we wanted? Let's see. If I make 2 here and I make 2 here, then I add 4 here, it is going to become 6, and 2 also become here, and then 4 also get added, so it is also going to be 6. After that 4 4 and 0. So 266, like 0266440, this is what we wanted. So in order to have like in order to add any value to a given L to R range, just make a of L equals to difference, and a of R plus 1 like equals to k and minus k. How this is related to our previous problem? Of course it is related. This is something which is the optimization that we were trying to do. Here you can see that this is something which is causing of n cross W complexity, and now we are going to like reduce it. How to reduce it? I'm going to have a separate array. This array, I'm naming this array as heights, or even call it increment, and it is going to have size n, and this is going to tell me how much height is going to be increased for each index. Let me explain. If I have like 6 flowers, like 2 2 2 2 1 1, this is again the similar example, the same example that I have explained you in all the approaches and even the problem statement, and I have 0 0 0 0 0 0 here. So I have not increased the height of any flower, but if I have 2 here, then it says that although we have the height equals to 2 initially, but now I have increased this height by 2, so total height is something which is equal to 2 plus 2, which is 4, and it is a of I plus heights of I. Now, where to perform the like query operation from L to R increments? This is where we are going to perform the L to R operation increment, and this is because this is something which is going to give me the increment. So this is where I am going to perform the operation. How? If I want to increase the height from this point to this point, so I'm going to by difference. By difference, difference is something that you know. What is the difference? Difference is this one, this thing. So if I want to increase the height from L to R by difference, so just do the same operation that I have told you. Make like h of L as plus equals to difference, and h of like R plus 1 is going to be minus equal to difference, like difference, isn't it? So just do it. Now I'm going to write pseudocode. So I have the height array, and I'm going to run a loop for I equals to 0 to I smaller than n and I plus plus. What I'm going to do, I'm simply going to like first of all I'm doing the prefix sum. Like as I'm moving, I'm also keeping track of the prefix sum. Height of I equals to height of I minus 1, like plus equals to this something does the prefix sum for us. Now I check if total height is less than total height is less than equal to mid. This is what we are checking. Mid is something that we want as our minimum height, and total height is this one that I already explained you what is the total height. If it is less than mid, then I'm going to calculate, first of all I'm going to calculate the difference, because I have to increase this value, and by what? This is something that is going to be mid minus total. Total is again in this in the place of this total I have to write this. After that I'm going to increase my days by difference. This is also I have already explained you, but the new thing that I'm going to tell you now, that instead of that for loop, that time consuming for loop, I'm simply going to do heights of like I is going to be plus equals to difference, and heights of I plus W, I and W like W values ahead, I'm going to do like minus equal to difference. Either I do plus equals to minus difference, both means the same. So this is how we are going to perform, solve a problem. So now we are done with the like possible function as well. Here I have tried my best to give you the like clear explanation. So and the even the video is I think it's too much long, but now I'm just going to jump the code. So here I have written the C++ and Java both codes, and I'm going to start from this point. This is something from where our solution start. So I have the minimum height as 0, but as I have explained you, we are going to take it 1. Similarly, we are going to take it, okay, 1 and 10 is to the power 10 and 10 is to the power 10 here, and let's take in minimum height as 1. After that, I'm running my binary search here. So this thing I have already explained you is valid, make it is possible, doesn't matter the function name. So I'm going to find the mid here, and after that I'm checking whether it is possible. If it is possible, then store the current mid in the answer, because it is a candidate for the answer, and else my my min and even my min will become mid plus 1, because I'm going to check for greater values. And if it is not possible, then my max will become mid minus 1. So this is how we are going to reduce our search space like in a binary search manner. After that, we have a function which is checking is possible. You guys don't have to worry about the code, because I'm going to provide the code in the description of this video. So I just want you to understand what I'm doing here. I have the heights array that I have explained you why it is why we are going to have this. Even you can call this a increment array. So this is something which is increment array, increment array. And now I'm going to have all the values 0 in this array first. Simple here again. After that, I'm going to have my days initialized with 0. So my days are 0, and I'm going to run a for loop. In this for loop, I'm calculating the prefix sum, and this condition is quite simple to understand, that I minus 1 should be greater than 0, because else it will cause like index out of bound error. After that, if my total height, which is the current like a of I is smaller than mid. Okay, one mistake that I think I was doing here is like I was checking equal to mid. Just don't check equal to mid, because equal to mid is something which is good. So we have to find like only smaller than mid. If it is smaller than mid, then calculate the difference. How much we have to increase the height? We are going to increase the height by that like value, and going to increase my days. After that, this is something that I have already explained you why I am doing this, because this is going to give me the solution for range sum query. So this is how we are going to solve a question. And after that, at last, this is one most important condition which is going to check whether I have utilized the day which is less than given number of days, because we can't take more than given number of days. So this is all about this solution. I hope you guys like the solution. If you like the solution, then